And more specifically, continuous deployment. In a Dutch company, a large Dutch company, where we ended up doing, after the whole project was done, we ended up doing about 50 deployments per day. On a system that had high availability, so was not supposed to go down unless we intended to do, and had a series of databases attached to it. And that meant that we had, from time to time, we had to do database migrations. And so the talk that I did here last year, I did it at a number of conferences, and typically people responded to me like, okay, you really haven't touched databases. Because if you do 50 plus deployments per day, and you have database migrations, how does that work together? Because a database migration typically requires downtime to do that. And if we have a highly available system, which is supposed to be up at least or almost 24/7, I would say, 4 nines, 5 nines, depending on where you end up, how does that work together? And so the question is always, how do we do that without downtime? So let's get into it. Database migrations, when I talk about them in the context of today's talk, I'm talking about database schema migrations. And a database schema, let's talk a little bit about what that is, really. This is one of the pictures you could think of when you discuss or think about a database schema. Most databases don't look so nice and organized and structured as this one. But we're talking about relational databases here, mostly, RDBMS. So you have your primary keys, you have your foreign keys, you have indexes, you have the whole shebang associated with relational databases. Relational databases, or their schema, are typically expressed in bare bones SQL statements, like this. We are creating tables, we are setting types for columns, we're setting types for keys, we're associating keys with other tables, etc., etc. And this creates a database schema like most of us are used to, or at least have seen once or twice in a relational database. So we're talking about database schema migrations. And like the schema itself, a database schema migration or change is typically written in simple SQL statements as well. And when we talk about schema migrations, most of the tools around this concept think of define two different directions. And the first and most important direction a database schema migration can go in is up or next. And the up is basically forward change. So we're changing a database version from version 1 to 2. So we're actually changing something from what was to what should be. And when you write that in SQL, it could, for example, be we create a new table. We add a new table to a database. Some tools also add a down direction or backwards in time, which basically means we are undoing or unrolling whatever we just did in the up direction. Now, not all tools support this, and I'll get back on that in a little bit. But if you look at a down from the creating a table perspective, well, the down would be dropping the table again. And this is a very simple example, but you can imagine that it becomes more complicated when you have slightly more complicated up statements. So this is about, these are the two directions we define in database schema migrations. Typically, depending on the tool again, database schema migrations are executed in the context of a transaction, which means that if a schema migration fails midway, the transaction is actually rolled back, undone, and it's as if the schema migration never happened. At least that's the intention. When we talk about tools, we look at a few different tools. These are some of the tools you can see in this space. There's many, many more, but these are some of the more popular ones and tools that I'm more familiar with. Flyway and Liquibase are, I think, one of the biggest in this space. And in this talk, I will concentrate purely on Flyway. Not necessarily because it's the best tool out there, because most of the tools essentially do the same thing, It's the tool I'm most familiar with, and it's one of the easier to work with, I think. Flyway is a Java-based tool, which does not really matter because it's mostly executable from the command line, so you don't really have to interact with Java at all. If you want to, you can, but you don't have to. Now, Flyway has a nice thing in that it writes its schema migrations as bare SQL files, and that's it in the standard mode. So there's no sugar around it, there's no syntax, there's no code, it's just SQL. And the files are typically prefixed with a timestamp or a date or something to have a sort of a sensible order. And then after the double underscore, we write the description of what the intended change of this migration is. And then we simply add the migration as SQL statements, quite easy. And then on the command line, we actually run Flyway migrate, and that's it. It will connect to your database, whether that's local or production or what have you, inspect the current version of the database, and then run all the migrations that need to be run against that database. And then once everything is successful, your database is now at the new version. How does Flyway record all this information? Well, it keeps an additional table next to all the tables that you write on your own, called Flyway Schema History. And in that table, it records all the schema migrations that it has executed before, when, why, by whom, how long it took, all the information that you would want to know about a schema migration, and also, of course, if it failed or not. So it records all that in the Flyway Schema History table, and then it simply checks for any migrations that you haven't run before and applies them to your database as well, and then records them in the table. Now, if you have an application which already has a database but has never recorded schema migrations in such a way, Flyway offers a way to actually introduce itself onto that database, as it were, to actually link itself to an existing database. So what do? Well, we actually start with saving the schema of your existing database, and there's a bunch of tools to do that. For example, if you use MySQL, there's a MySQL dump command which not only stores all the data, but stores the structure of your database as well as SQL statements again. And that is essentially the initial migration of your database, right? And that's the state your database is currently in. So what we do with Flyway is we actually add a base version as an SQL file, and we copy paste all the, essentially the snapshot of our current database schema in there. And that's our base. That's where we started off from, or where we're starting off from. And then we have to actually tell Flyway, you don't have to execute this migration because this database is already in this state, right? So we only have to say to Flyway, okay, this is our baseline, and don't actually execute this schema or this migration, but consider this to bring the schema to where it is now. So it's like as if we executed that migration, even though we really haven't. But now Flyway knows, okay, the database is now in a state where I know it to be in. And from that point on, we can add new migrations. It records it just as all the other migrations in that history table, but it has a specific type, like this is the baseline, this is where it all starts off. And then we can add additional migrations and build on that. And so we can switch our legacy database to actually have migrations, which is pretty cool. There's a couple of other things that Flyway supports, and that is a repeatable migration. For example, if you have a table which is supposed to be filled from data periodically, or a view needs to be recreated, or a trigger needs to be recreated, every run of Flyway, the repeatable migration is run again, hence the name repeatable migration. If you want to write Java code in a migration, you actually can, which means that you can, while running a migration, you can pull in data or structure or other things from other sources that you can interact with from Java code, which would make your migrations a lot more powerful, but also a little bit more complicated. But it's possible, and that's pretty cool. Callbacks, again, this is Java code, so if your migration finishes or fails, let's hope not, but if it at least finishes, your callback is executed. And this is straight Java code, so your callback runs, and then you can do something. You can involve somebody, or you can clean up, or whatever you need to do. And then there's a pro version, which I'm not advocating you need to buy because it is pretty expensive, but it supports, among others, Oracle support for those that really need it. It supports custom error handling, and it supports undo migrations. So remember I talked about the back direction, the undo direction. In the default mode, the community mode, Flyway does not support that because they say it's pretty complicated. We'll get back to that. But in the pro version they do. So undoing migrations. Flyway does not support it in the free version. In the pro version it does. Other tools like Liquibase and Doctrine and more tools, they actually support it by default. But should we do that? Undoing migrations is all about the question, do we actually roll back or roll forward? Rolling back a change that failed, or do we fix a change that failed? Now, when we talk about this in the database context, let's consider a few things. Destructive changes. Destructive changes to a database and to its schema. Long-lived locks can be destructive in terms of not being able to store any data or change data in your database, as long as the table is locked or anything else. Renaming columns or tables is a destructive change, right? This is a rename is essentially a delete and an add, which makes it destructive. But straight deletes, of course, are destructive as well. Now, there are some database technologies that do implicit commits from time to time. MySQL is notorious and was notorious for this behavior, that if you do certain alter table statements inside a transaction, it would actually commit the transaction and start a new one without telling you. This would be implicit behavior, which also means that the transaction that was auto-committed is now hard, if not impossible, to roll back. And you need to be aware of that. Today's behavior of MySQL is a lot better, and I don't believe Postgres has this behavior, which is cool. But Oracle in some versions really does, and that kind of sucks. Then there's sharding. If you have a sharded database, then undoing something is really difficult, because if you do it on one shard and then on the next, and the second shard fails, do you need to roll back the first as well? Maybe. Can you? Question. Or if you have multiple databases, you don't only have MySQL, but you have a Postgres lying around as well. And you may have an Elasticsearch as well, which is not transactional by its very design. Or you have a Mongo, and you have views on the same data, and one of them fails. Do you roll back? Can you? Can you restore from a backup? Well, that's a good question in itself. If you don't have any data added to your system between the time of the backup and now, then yes. But on a zero downtime, highly available 24/7 system, the chances of you having data added to your system since the last backup are almost 100%, which means that if you restore from a backup, you need a way to actually replay all the data that you missed since the backup window. It can be done, but it's difficult. So my view is that in a live system that receives a lot of writes, a lot of changes in a zero downtime, highly available setup, rollbacks are not realistic. And that means that if a migration fails, it's simply stuff to clean up later on. And that also has an implication on what kind of migration we can do. And I'll get back to that in a little bit. Let's consider downtime, because I've mentioned the word downtime a few times ago, or a few times already. And let's look at what downtime means for us from a deployment perspective, and then switching over to databases again. So let's take a look at a very simple deployment flow for a very simple application. Your hello world in Go, in Docker, in 5 minutes. So you build your hello world image. This is easy. There's tons of tutorials online how to do that. And then we stop whatever we have running. So far, so good. Then we run our migrations. So far, so good. And hopefully they all work and they are timely and speedy enough. And then once they're all done, we start the container. Cool. And we have really no problems here because we have a database that does not receive any writes or reads while we're doing the migration, so we're kind of isolated here. Very cool. But there's downtime. And in some cases, this is definitely acceptable. If you have a system which only runs from 9 to 5, then maybe you can do this at 6 in the evening. However, you've already been working for 8 hours, so is that a sustainable business model? Maybe not. That's all a big question, and very much it depends on your use case. But if you have, on the project I was talking about last year, you have a system which runs almost continuously, and especially during working hours and the weekend. You cannot take the weekend to take the site offline. That would hinder people. That would cost us money. And we don't want to do all the releases at night because I like to be home and take care of my family once in a while too. So sometimes, or a lot of times maybe, especially in this day and age with live real-time systems, downtime is not acceptable. And let's consider continuous delivery as a principle. Continuous delivery states that code or an application altogether, it should always be in a releasable state. Continuous delivery says that we deploy automated to acceptance, to staging, and we manually, or at least a manual trigger, we deploy to production. So we validate whatever's in acceptance, and then at some point somebody will push an actual button maybe, and it will be deployed to production. But the key thing here is code should always be releasable. So if I run into the room and I say, okay, Carlos, deploy it right now, and he still has to run a migration which takes 5 hours and takes the site offline, then is the code releasable at that point? Not so much. And especially if you then talk about continuous deployment, where we say that code that passes all the automated checks and tests is actually automatically deployed to production, like so. We have no human involvement anymore in the pipeline. We deploy automated and, well, fully automated to production. Then there's no room for a migration, especially not one that takes minutes or hours to complete. And let's consider the zero downtime deployment scheme. If you have, of course, there's, you know, your Netflix, your Alibaba, your Amazon, they do this at a scale which is mind-boggling. But even smaller sites, smaller systems, smaller applications can benefit from zero downtime deploy. Let's consider we have an application of a version, say 1.0, behind a load balancer. This is a very typical setup. And then we want to release version 1.1 of that application. So we start it and we let it boot, and then we add it to the load balancer and it starts to receive traffic, and we validate that everything is going well. So far so good. And then we give it all the traffic, and then we yank out the old version of the application. And we delete it. If we do this right, then nobody will have noticed that app 1 was replaced by app v2, right? And that makes it a zero downtime deploy. We actually deployed a new version of our application, and nobody notices the difference. Good thing. So we have no downtime. But if we want to combine that with database migrations, well, then right now we have actually only one option, and it is don't run any migrations, and then you don't have any downtime, which is pretty cool. So end of the talk. We're done. Not so much. You're all here to learn from me, hopefully, how we can do this and get rid of that pesky downtime. Let's consider what our database state has to say about all this. Let's consider again the load balancer and the app version 1. Now, in this case, app version 1 is actually connected to a database of version 1, or a database that its schema is at version 1. So the app version 1 actually expects the database schema to be in version 1 as well. So far, so good. Now we add a migration. And all of a sudden, the database schema version 1 is no longer version 1, but it is now version 2. Does this work? Well, it could, maybe, but potentially it will break. Because the schema that is expected by app version 1 is 1.0. And now we actually changed the database schema without informing the app. That was not so cool, right? We were not so friendly to that application. And we then deploy app version 2, which actually requires database schema to be in version 2, and that totally works. So we now have a situation where we have simultaneously 2 versions of the application running side by side, and this is, there's a good chance this will happen if you do 0 downtime deploys. But you have a database or a database schema which is only compatible with one of the 2. And that kind of, depending on, you know, in this setup, you would have a 50-50 chance of getting a broken page or a broken application, broken service. So let's get rid of that. And that means that the old application should always work with the new database state. So instead of doing the things together, we actually do them in separate steps. And the old application should always work with the new state, which allows us to go 1 diff back, or 1 build back, or if you do git revert hat, without actually touching your database. Because the database will support both versions, and that's cool. How do we get there? Well, we want to essentially decouple things. We're all about decoupling in this industry. But in this case, we want to decouple the migration from the deployment. Whereas previously, we actually wrote the migration and the code associated with the migration and deployed them as one thing. And that means that the migration needs to be done, needs to have finished before the code is deployed into production. We want to actually split those 2 things apart completely. And let's take a look at a pattern which allows us or helps us to do that, the expand contract pattern. This is a design pattern which you can apply to code, but you can apply it to databases and APIs and other things as well. And the expand contract pattern is all about backwards compatibility. And this is the key thing in database migrations without downtime. So consider we have an existing API, and you can read an existing database schema or an existing interface or something else for that, and we add a new API. Now, we could have simply changed the existing API and we would break all these clients, right? It would be completely backwards incompatible change, potentially. And people would be very upset with us with good reason. So what we instead do is we start deprecating. We start deprecating the old API. And we give our clients time to switch over to the new API, one by one. And this phase is called the expand phase. Why? Because we intentionally are duplicating stuff here. In this case, we're intentionally duplicating an API. We're building a new API side by side next to the existing API. So we're intentionally expanding our system, and then everything is switched over to the new API, and now we're in the contract phase. So we're actually reducing again. So when you apply expand contract over time, you'll see your code base, your API, your database do this, like an harmonica, expanding and contracting. And expand contract is all about backwards compatibility and non-destructive changes. Depending on the database technology, the tolerant reader pattern is a thing as well. I'm not going to go into that, but if you want to read more on that, there's tons of information online about the tolerant reader. But non-destructive changes from a database perspective mean adding things, right? Adding tables, adding columns. If you add a table your application does not know about, then it does not hurt anybody, right? It's just an actual table. And columns as well, and creating indices, usually. It depends on the database engine. Let's go into a concrete example, renaming a column. Let's assume we have a column surname, and we want to rename that to last_name. Pretty trivial example, but it's going to be a little bit complicated nonetheless. Because instead of simply doing an alter table rename, we're now going to create a column with the new name. So we're going to add last_name to our table. And notice that we are actually keeping it nullable. So we're not setting any defaults, we're keeping it nullable. Then we're going to write to the old and the new columns at the same time. So we're going to write to both surname and last_name at the same time. From, for example, Java code, this could look like this. The moment you set last name, which is your new your new column, you also make sure to set surname as a fallback. And if you get last name, we first try the new column, but if that's still null, we revert back to the old column, surname. And then we start migrating old records. In this simple example, that could be like this. We set the last name to surname where the last name is still null. So all the records that we did not touch, we're going to touch manually now or with this update statement. And then we're actually going to read from the new column because now we can enforce that the new column actually has data. And now our get last name is simply returning last name. And then as a final step, somewhere down the line when this is all stable, we need to remove the old column. So this is surname and the associated code. And we're done. That's it. That's database migrations without downtime. There are a few caveats though. A small side note about testing migrations. This is one of the questions I get asked often. How do you test a database migration? Well, there's one simple test, and it doesn't actually test whether a database migration is right, whether it's correct, but it only tests whether it can actually run, and that's more than not testing it. So in your CI/CD pipeline, what you can do is spin up an empty database instance. So a container for MySQL, for example, or Postgres. Spin it up and spin it up empty. And then you run all your migrations in the right order, from oldest to most recent, against that previously empty database container. And then you assert whether all your migrations actually ran. So on an empty database, all your migrations should run. And this is the test whether your SQL statements are actually correct SQL. It does not test whether your data gets lost, whether it gets transposed or transformed correctly, because these are very difficult things to detect, very use case specific, but at least this allows you to test whether your system or whether your migrations altogether work. You can also run migrations on staging and acceptance before you run them on production. That is also an option. What you can also introduce is a thing called the feature toggle or a feature switch. What does a feature toggle do? Feature toggles allow you to enable or disable features, functionality in your code, and basically enable or disable alternative code paths in your system, in your application. And do that at runtime, which is pretty cool. From a web application perspective, that could look like this. We have an old search page on the left and a new search page on the right, where we have a feature toggle in between, which actually allows us to switch on or off the functionality that delivers the new page, whether it's ready or not. And we can even, write a dashboard where you have on and off switches where you can switch off particular paths in your code for particular groups of consumers. But translating that to databases, let's go back to our renaming a column example. We could actually put writing to the old and reading from the new behind the feature toggle. And then we can write all this code and deploy it all together and test it. And then once we're ready, we'll flip the feature toggle switch on first acceptance and then on production. So that allows us to decouple. Yeah, this is alt slides which I need to skip over. Sorry about that. So let's take a look at a few challenges which are associated with database migrations and downtime. One of them is long migrations. I've seen situations where you have database migrations which run for hours or even days, which is a pain. Some database engines lock your tables when removing columns or when selecting large data sets. Can also be a pain. Another thing is failures and restart. Murphy's Law applies here, and migration typically crashes at 99.9%. And does it require a lot of memory to run it? Either on your database engine, your database machine, does it require temporary tables? Does it require a lot of memory buffers? Will it require a lot of network or I/O? All those things can slow your migration to a crawl or all the other data queries on your database table. Cleaning up. you need to be mindful of removing old columns and old tables and old leftovers that you added. So this is a thing that you need to be aware of. Logging and progress reporting is a very useful thing. Where is your migration? How is it doing? How much time do I still have left? If you're interested in learning more about logging and progress, there's a post-mortem by GitHub where they actually looked at how they had a split brain scenario and they had a serious outage a couple weeks ago, 2 weeks ago, and they looked at their progress indicator, and that gave them a lot of false data. But that's very interesting. I won't go into more detail than that. And non-nullable types. So if we add new columns, make sure that they are nullable. And when you are sure that then the new column is filled with data, then you can add a constraint to make it non-nullable. But that depends on the database engine whether that causes a lock as well. Okay, let's close off with a few strategies how to deal with some of these things. And one of them is pretty cool, but very ops intensive. And that is running things in a replicated scenario. So what we're doing is we're going to run the migration on a failover. This assumes that your code that requires the migration and is backwards compatible has already been deployed. And like I said, this is very ops intensive. And why? Well, let's consider the following situation. We have a master and a slave of the same version, the MySQL setup or Postgres. We have a simple situation where we have two replicas, or one replica and a master. And what we do is we take the slave out of rotation first. So we stop its synchronization. And what we then do is we actually run the migration on the slave. So the slave is now going to be at a new version, or at a different version compared to the master. So we need to be aware of this. This only works, by the way, if you do statement-based replication, in MySQL at least, not row-based. Because statement-based replication, MySQL will actually figure out that in this version, if you see a statement with surname still, it will actually drop it on the slave. Row-based, not so much. And then we start the slave synchronization thread again, and we let the slave catch up to the master. And this will work even though we have surname removed from this slave. It will still work because it's statement-based replication. And we let it catch up, and what we then do is actually trigger a failover from slave to master. And now the roles change. And all of a sudden the master is now at version 2.0 because we just switch over, and we have a slave which is running behind. And then we do the exact same thing. We take that slave out of commission. We apply the migration on that machine, and now that's at version 2.0. We let it catch up again, and boom. We have run our migration on a replicated setup. And you can see why this is a very ops-intensive system. There's also another option, is running things through a queue or a message bus. Imagine we have a UI layer at the top of the picture, and then we have a queue which gets messages from the UI, like this field was changed or update this. And those messages get passed into a backend, which then does things with the messages, right? And then the backend changes the database based on those messages, and the database is again queried by the UI layer. So this is a pretty straightforward setup. And what we can do here is actually take the backend out of the system, and the only thing you will notice is that the database does not update anymore. But the queue will start to fill up. But we can actually change the code in the backend and change data structures on the backend without having problems with the UI. And then once that's all done, we have changed our database, we run the migration, we actually plug in the backend again and let it catch up. There's a pattern called CQRS, which actually is applicable here, which stands for Command Query Responsibility Segregation. That's a lot of expensive words for a simple thing, a simple pattern, which is separating writing from reading. And what you can use here, for example, Kafka or any other message bus system. And what you do is you store any updates to your database in a log, in a message log, essentially. And like a binary log in MySQL or Postgres, you have a commit log where all your writes are attached to the end. And that would look like this. So your messages get passed into Kafka, and they're written to a commit log and read from there. And when we then need to change, or maybe even change database technologies, we can replay the entire log and actually rebuild things from the commit log. We can even rebuild the staging database based on production data, maybe even anonymize the data while we're doing that. And so you roll in a completely new database technology, and you can potentially even deprecate an older database. Okay, the last tool I want to discuss with you before we kick things off is the PT Online Schema Change tool. And what the PT Online Schema Change tool is actually doing is it uses triggers to fill temporary tables while you are doing a migration, while still allowing writes to a table. There are a bunch of similar tools as well, but this is what started it all, I would guess. And basically what you do is you create a shadow copy of a table. You create a copy of the current table, of the schema of the current table, and then on that shadow copy, which is now your target, you run your migration. You change that table. And because it doesn't have any data, that's very quick. And then we are adding triggers to the existing table to forward any updates from the source table to the target table. And then in small chunks, in batches, we're going to actually copy the source data from the source table to the target table in blocks. And once that's all done, we simply rename the target table to the name of the source table, and hey presto. Now this is not the end all be all. This is not the tool that will solve all your problems, because it does not handle foreign keys well, because foreign keys cannot be copied. It can be very disk intensive, especially in this part, and it can give your system performance issues depending on how this all works. And not every tool is resumable. So if the tool crashes, then you may have to start all over again. But it is a very good tool to have in the box of tools. And that would look a little bit like this. So what we execute is actually, we run it on a table test1, and we have an alter table statement which adds something to that table, and then PT Online Schema Change will create the target table with this statement applied and forward all the changes. And there's a couple of tools more. The Large Hadron Migrator from SoundCloud, there's a Facebook tool, and there's something from Twitter, and there's all sorts of other tools that you can use as well. They pretty much do the same thing. The Large Hadron Migrator integrates directly with Ruby, which is interesting if you do Ruby, otherwise maybe less interesting, but there's a whole bunch of tables or tools in this space which can be of interest. Okay, let's recap what we all went through today. One of the key parts of doing database schema migration without downtime is actually taking care of your planning. So before, we had things in a single step. We wrote our migration and our code, and we deployed those two things as a single unit to production, and we required the migration to have finished before the code would work. And instead, we're going to do it in multiple steps now, and multiple steps that don't invoke any breaking changes. So the old application should always work with the new database state. There's some literature that I want to give you before we close. The Refactoring Databases book has a bunch of patterns around this topic that you can apply as well. There's an associated site, databaserefactoring.com, and there's some things about this in Barsam's dev book on database refactoring as well. All right, thank you so much for now. This is my Twitter handle, my email address, and my website where I blog about continuous delivery, DevOps, event sourcing, databases, what have you. All right, I think there's time for questions if there are any. Let me switch to the Slido thing. If you do 50 plus dB schema changes per day, how do you clean up the mess and make sure no one will rely on columns that are supposed to be contracted? Okay, we weren't doing 50 plus schema changes per day, because that would have screwed my day considerably if it would be. Plus, we would probably be doing something wrong if we really needed 50 plus deployment or schema changes per day. But let's assume we are doing that. How do you clean up the mess and make sure no one will rely on columns that are supposed to be contracted? Well, one of the things you can do is actually when you are preparing a story, when you are discussing how to build some functionality with your team, this needs to be a task. Clean up, contract, essentially. So this needs to be a specific task that you all need to be aware of, like, okay, we need to write the migration, we need to write the code, it needs to be tested, etc. Those can be tasks. And then the cleanup should be a task on its own, I would say, so that we don't forget it and that we can address each other when it doesn't happen. Are there any other questions that I can answer? And otherwise, I will be here the rest of the day and tomorrow as well. And you can find me for any other questions. Cool. Thank you for your attention. Have a great day.